All right, we were talking about various kinds of input splits. Okay, so we will talk a little bit more about input splits. And in case your data is in the form of fixed length, as in every field has got fixed size instead of field separator, generally files are field separated. Files are some field separated, for example, comma separated files, tab separated, or some other special characters. Okay, some of the files are contain fixed length records. Okay, whereby the records are separated based on the fixed size. In those cases, you should generally use fixed length input format, meaning basically specifying fixed length input format will optimally load records using this particular format. So input format converts the raw data available in HDFS into the it converts the raw data into the records. Okay, and what is a record? Each record is going to be fed to your map task, and for bunch of records called input split, for bunch of records which are called input split, we are going to create Hadoop is going to create your mapper. It's going to initialize mapper for the whole input split, but it will run your map logic for every record inside that input split. Because if every time it's going to run your map logic, if it initializes every time for every record, it's going to be extremely slow, because initialization of any class or initialization of any logic takes time. All right, so while your map logic consumes one record at a time, the overall class is initialized for the whole input split. Okay, so fixed length input format makes sure that the record size is fixed. Okay, which you can set in the configuration. Next is key value text input format. Sometimes your input data is in the form of key equals value, then new line or some other character, then another key equals value, or key the separator value, then new line or some line separator or record separator we call them. Okay, so in key value there are two kinds of separators, and both kinds of separators, one separates one record from another, and another separates key from value. Okay, so another input format which is there is called sequence file input format. Okay, and what is a sequence file input format? It reads a format called sequence file. And what exactly is sequence file? Whenever you have to store data in binary format, you generally use this sequence file. Sequence file supports binary key value data, as in raw machine readable key value, which is not plain text. And the sequence file has got a detailed header. Okay, so essentially when you look at music file or a movie file, internally they look like sequence file. All right, so the most interesting part is that most of the zip files can be converted into sequence file. Now question arises that what would you do if you have very small files such as the Facebook profile pictures? So let's say you have to store Facebook profile pictures of all the people at Facebook. Now, how would you store such pictures in HDFS? Let's say we store it just like another file, but given the fact that each picture is hardly few kbs, okay, it's hardly like 5-6 kilobytes, which means that picture is going to consume the metadata space equal to the one file, right? So one file, whether it's 1 byte or 10 byte or 1 gigabyte or 1 terabyte, it's going to consume the metadata space. So the file of size 128 MB and a file of size 1 kilobyte both consume equal amount of metadata memory in the name node. Which means that if you have 1 kilobyte file, okay, and there are 1 million such files which are 1 kilobyte, or let's say you have one file which is of 128 MB, okay, I'll just come back again. So 128 MB file, single file, would consume metadata space equal to 1 kilobyte file. Note the metadata. We are not talking about the actual blocks. Actual blocks will basically, in case of 1 kilobyte, there will be one block of 1 kilobyte size, and in case of 128 MB, it's going to be 128 MB block. So, but metadata for both the files are going to be same. All right. So generally, let's say you have 128,000 files. Okay, 128,000 files, you zip them, and you will have one file. Okay, so you can see that you have reduced your metadata by 128,000 times. Okay, by zipping it together. So what you do, you take all the files, convert it into zip, and then convert that zip file into sequence file. All right, so whenever you have many files, many small files, you generally can zip them, and zipping is better if you are going with something like LJADO format. Okay, you can go with LJADO format for zipping the data. Okay, or tar format, because these are more efficient formats when it comes to HDFS. The beauty about sequence file input format is that it can be loaded very efficiently in Mapreduce. Otherwise, if you are going with any other format, you will have to bring all the blocks onto a single node, and then you will have to do. Okay, but if you are using a format like sequence file input format or a compression format like LJADO, you will be able to efficiently load it parallelly on various nodes. You can uncompress the partial data. Okay, you can directly read files inside your mapper like this. Sometimes what happens is you cannot specify that this file is to be splitted and used parallelly on MapReducer. Okay, sometimes you don't want to specify a file as the input for your MapReducer. Instead, you want to load this file on every node inside every mapper. In those cases, you can read the file using this particular API. All right. Similarly, there are these tools which can help you converting a ggip into splittable, and also how to use the Hadoop LJADO. All right. Now I wanted to go through the Java part. All right. So why do we need to do MapReduce in Java? The main single reason is the primary support. And why is there a primary support for Java? Because MapReduce component or Hadoop as whole is written in Java. And why is it written in Java? Because they wanted MapReduce to run on all kinds of platforms, because it has to because you might need many devices. So that is the reason they wanted the Hadoop to run on all kinds of devices. So they wrote it in Java, although as of today neither Hadoop, neither Hortonworks nor Cloudera lets you run on different kind of devices. Okay. All right, so the simple mechanism we will follow is we are going to use Eclipse. Okay, so first step is to install Eclipse and then create a Java project and then add a library, add the libraries which are provided to you. Okay, so let me show you. First go to no big data, go to my courses. Okay. Okay, so you go to the session number 4. Okay, and then from there you can download the sample project. Okay, once you download the sample project, you will have the zip file locally available to you. Okay, so you can download a sample project. Okay, it's a 53 MB file. All right, and then what you can do is you can start Eclipse. I'm going to create a fresh project so that you have a clarity on how to do. Okay. Okay, so it's doing something. All right, so right now this screen has come, and let's just say file new project. Okay, file new project, or you can say import. You can say import. So you can import an existing project into Workspace. So this folder which you are trying to right now, we are downloading. I already have one copy of it downloaded to me. Okay, available in here, and let me just look at this project. All right, so this one I have already already a local. I have a local copy here. Okay, it has two folders. One is library, which contains all the libraries that are required for it, and the other part is these. Okay, other part is the source code. Okay, good that it's also downloaded now, and also it has been unshipped. Now what you have to do is select the trg2, which is my training project. Okay, so you can see now it has detected that this is the project contained in trg2, and I'll say finish. Okay, so this freshly downloaded project has been imported. We can close it comfortably. And this side, you will see the reference libraries. Okay. This side, you will see reference libraries. For you, these reference libraries are going to be wrong. Okay. So you will have to modify these libraries. Okay. And how do you do that? You go here, go to properties. Okay. And go to Java build path. All right. And then you can go to libraries and remove all of these. Okay, you remove all of these except for JRE. Okay, so I've selected all of these and clicked on remove. Okay, and then I'm saying add external jars, and the folder which contained libs, you go inside that, select all and import. Good. So we have successfully added the jars. Jar means the bundle of code. Jar, tar, zip, all of them has a similar behavior. They are the bundles of files. Jar and tar both are same. Okay. Okay. So now we have our project successfully imported. There are no errors whatsoever as of now. Okay, now what we're going to do is we are going back to the slides. First we understand, so we are here up to this point. Okay, so you can generally, it's a general tip, when it's a good practice to have whenever you are compiling, whenever you are compiling for any framework, you generally you generally go with the lowest possible compilation. Okay, what does it mean? It means that your product, when it get built, it can run on every Java virtual machine starting from 1.6 onwards. Okay, and how does it help? If you have a big cluster, or if you have a big cluster, the chances are that your sysadmin will not upgrade versions of Java too frequently. And that's a truth for every kind of environment. Sometimes you will find that on the cluster they are using a very old version of Python. And then, if you are not careful about it, you will keep cribbing about that it works on my desk, it works on my computer, it is not working on the cluster, there's something wrong with the cluster, it's not my fault. Okay? So whenever you're building a product, you need to be compatible with lowest version possible. Okay, so that your product can run on many platforms. All right, so therefore you should generally choose a lower compliance level. 1.6 is very safe. As of now, everyone in industry would be using anything above 1.6 plus, because 1.6 was released in around 2009 or 8. Okay, so now the errors are gone, everything is in shape. All right, now what we can do is, all right, so our compiler settings are set to 1.6 and whatsoever. All right, now the important part here is the mapper. First of all, you have to create a class called mapper. Once you have a project, here you have the project. In case you did not have these files, you will be creating first a mapper. Okay, first you will create a mapper, and so this is the name I have given. You can give any name to your class. So first thing you do is create a mapper. What does it mean by creating a mapper? Creating a class. Creating a class that extends mapper. Okay, and in what way does it expand a mapper? It extends a mapper such that the key is object. Okay, and the input line, so it basically concretize the definition of mapper. Instead of saying generic, it is concretizing the key value. It's saying that our stub mapper is a mapper of type object, text, long, writable. Meaning, these are the four data types of input and output key and values. Okay, this is input key, input value, output key, output value. So these four data types is what defines the data type of your mapper. Okay, so our step mapper will take object as key, the keys data type will be object, and the input value will be text, and the output key will be text, and output value will be a long writable. All right, and then the mapper will, you can see that whatever data type you have defined here, same thing you will have to define. Whatever first two, the input one, these two you'll have to define in the map function. Okay, and then context. All right, so although you have flexibility in keeping this name anything, okay, but here the function name has to be map, and inside this will go your logic. This is the logic you have to write. So this is our stub mapper, which will get created for every input split, and this logic from here to here, from here to here, which is the function called map, will get executed for every record inside input split. Okay, so this is what exactly are we doing? For the input text, we are splitting it by space or tab, and After splitting, we'll get an array of words in each line. Okay, so the input which you'll get here is a single line, and that single line is broken into multiple words, and then all we do is here to spit out the key and the value, we say context dot write. This is the way your map logic is going to specify key and the value. You can call context dot write as many times as you want, meaning you can produce as many key values as you want. Okay, just that you will be only able to produce the data type which you have defined here. Okay, a little bit about data types. So Hadoop guys realized that the data types provided by Java are not good enough for Hadoop. Okay, because Hadoop has to transmit those data types over the wire to many machines and so on, right? So they had to serialize the data again and again and transmit it over the wire and so on. Therefore, they created their own wrappers for each data type, each basic data type in Java. For example, text is a wrapper over string. Long writable is a data type which is nothing but a wrapper over long, which is the basic data type, and so on. All right. So this is the definition of mapper. Here we are splitting the line and giving out key and value. And what is the key? Key is the word and value is nothing but a long, which is 1. We are creating by saying new long writable, we are saying that create 1. Okay, instead of simply saying 1, we are saying new long writable 1. It's like gift wrapping something. It's like gift wrapping a pen into a very big box. Okay, so here what's happening is, since Hadoop wants you to use the formats like long writable, text, and the other data types, therefore you generally wrap them and unwrap them whenever needed. Like for example, we are saying value dot to string here, meaning we are extracting the actual string from the wrapper from a big gift wrap called value, which is a text, right? All right, let's say for argument's sake we want to give out the value key. Instead of using word, we want to give out, let's say, a hash code as the key. In that case, what would we do is we will put it as long writable. The key is long writable. Okay, similar to this one. The output key will become long writable. Similarly, here we will say long writable and we will say hash code. Hash code is a function provided by Java. Okay, so this way. I hope that's clear to you. I'll show you in the real code. That'll be easier to explain. All right. So here is the same thing. A bit minor differences here and there. You can delete this. This is done for testing. All right. A few more details here. In case you want to see something in the log file or error output file, you can print the statements. Okay, this will go in the log files. Using this log files, you can always debug what's going on where. Okay, we don't need it right now, so I'm removing it. Now you can see, in case we want to output, instead of long, we want to output int writable, because let's say we say that our number is not going to be big, so let's have int writable. In that case, you have to change this to end writable. Okay, see, it started giving us error. It says that method write is not applicable for this. Okay, so we'll have to change this to int writable. Now there is no error. Okay, although there's a test case failing because test case has been designed for long writable. All right, now there are only warnings, no error. All right, similarly, we create a reducer. Please note that reducer's input data type are same as the output data type of mapper. Okay, so similar to mapper, we create reducer by extending a base class called reducer and concretizing it, saying, hey, I'm trying to create a reducer which takes the input key and the value in this format, in these data types, and giving out these two data types. All right, and then you create the actual reduce function called reduce, and then inside that you will do all your magic. Here please note that the actual value which you receive in the reduce is a list of values, not only a single value. It's an iterator, it's a list, it's like a cursor in the database. So you will get the key and the list of values for that particular key. The way when you say group by, all the values for that particular column get grouped by together. So by the time, so once Hadoop has finished grouping the data based on the key, it calls the reducer for that particular key, right? And therefore, the values is a list of values, it's not a single value. Similarly, we have context in which reducer can output the data, and right now all we are trying to do is we are trying to find out how many times a word has occurred. So we are saying long sum and sum plus equals to iw.get. iw.get basically opens the box and gives you that particular value wrapped inside a long writable. IW is a long writable, and we are saying get, meaning give us what's inside the box called long writable, which means we'll get the actual value. Okay, now we are happy that we have created a mapper and a reducer. All right, now this was mapper and reducer. Okay, now to make the magic happen, you have to write the entry point. Like in every programming language, you have some main method, you have some entry point. Similar to that, you have a driver. Driver is your entry point. Driver is the one who is specifying all the possible parameters to the MapReduce job. Driver creates the MapReduce job and hands it over to Hadoop. So here, first of all, you create a job object, and then you define that, hey, my jar's first class is this driver, and then my mapper class is this, reducer class is this, and the output key and output value is of this data type, and maps output key and maps output value is this, and so on. And also here we set the input path and output path, that read my data from this file, read my data to this file. Now we have not specified any input format. If you do not specify any input format for your job, it's text input format. By default, Hadoop assumes input format to be text input format if you do not define any other input format. All right. So once you're done with creating the job, from here we created an object, set all kinds of parameter, then we set mapper, reducer, the name of jar and name of the entry point, the class and everything. And afterwards we also set the input file and output file, and then we say that please wait for the completion of the job. So the code will, this driver will wait unless the job is finished. The Hadoop will launch the job in the background, and once that is done, system exits. The JVM running this particular driver will exit. Okay, all right. So once you are done with creating it, you export the jar. Once you are done, so let's just check. So our mapper is good. Everybody's okay with the mapper here? So it's created here. You can see that. You can see that it's created. Yeah, I'll show you the real code. This is our real mapper code. This is our real reducer code. You can see that. And driver is the real driver code. Okay. Please note that I have removed some piece of code from the slides in order to keep it brief. Okay. So here you can see that we are also doing testing here, saying if the arguments are not true, if you did not specify both the arguments while running the program, then it gives this particular error. Okay. Afterwards, first you create the conf object, and then you specify all the argument conf object to create job, and then you specify all the argument to the job object. Okay, and then you specify the HDFS input and output folder location, and then you execute it and wait for it to complete. All right, once you are done with this kind of Mapreduce program, what you need to do is you need to export it into jar. Just search for jar, let's say jar. Okay, and then all you need to do is just rename, give it a name. Let's give it trg2 fab 8. Okay, and finish. It says jar creation failed. Problem writing trg2 src icon. Okay, let's remove it. Let's remove these two. Okay, it finished with warning this time. Okay, no worries. All right, now is the important aspect. First you need to upload this jar to your HDFS and then copy from HDFS to your console local system, right? Because other way could have been that you do an FTP onto the server, which would be a longer route. So instead of that, what we will do is we will go into our here and then open Hue and and upload there. Okay, let's upload. This is my home folder. You can see here. All right, let's go into file browser and upload this. Not this way. Upload files. Okay, select the file which we are creating. Okay, where did we save it? I think we forgot to specify that. Okay, I think let's put it in downloads. Okay, let's put it in downloads. Now once we have exported into jar, it should appear here somewhere. Yes, it is there. So it has successfully uploaded. Now let's go to console. Okay, so what we have done, we have uploaded this jar onto HDFS, but Hadoop expects this file to be in the local file system, right? Therefore, we'll have to copy it first to the local from the HDFS, local as in inside console, the machine which is running the console. Okay, so here you can see that that particular file is not there, so we'll have to say Hadoop fs copy to local. Okay. All right. So we are copying that particular file from HDFS to my local directory. Now let's try to run it. Let's, instead of saying fs this time, we will say this. Okay. It says that please provide the main class name. Okay. What is the main class name? The driver class. Okay. The driver class name is step driver and the package is my. Therefore, we will be using my.stepDriver. Now, now you can see that it's saying that the usage is this. And where is it coming from? From here. That means we have been able to successfully reach till this point. Okay, we are able to launch our step driver, just that we have not provided any argument, so it is telling us that hey, you need to provide these arguments. Okay, now let's provide our HDFS location of input directory. Okay, and where is that? Data, mr, and word count and input, right? And then I'll say mr fab 8. Okay, let's see what happens. It has started the job. You can see that it is running the job. The process has been started. Okay, so it has saved the data somewhere and you can see that it is successful now. Okay, let's check if this folder has been created in my home folder. Let's see. Hadoop fs, sorry, we have to put ls. You can see that it has been created here. Good. We can check Hadoop fs minus cat and this particular file and say more. You can see that the output has been created, but again we are having the same problem. We have not cleaned up our input data. Alright, so we were able to successfully run Mapreduce. Okay, now sometimes what happens is say your mapper code right now, if you notice our mapper code does not have much, right? Our mapper code basically does nothing other than printing the word and the value. Sometimes the mapper code could be quite complex. The mapper code could be such that it's connecting to a database, sending an email, downloading website, or making any other network connection, or executing some third-party processes. Okay, so your mapper code is basically whatever you type here is should be a valid Java code and give out key and value. So when you have to refer an external library, say for example Java Mail or any other, in those cases what you need to do is you have to specify the libraries like this. Okay, you could say minus libjars a.jar, b.jar, c.jar, and so on. In case the argument are bigger, then you can define an external variable. This is a standard Unix shell. Okay, you could basically say things like libjars here, not here, in the console. Here, you could say minus use lib. Okay, minus a libjar, not use libjars, and say java mail dash 1.2.3. I'm just giving example .jar. If you are using java mail jar in your program right now, our program does not use anything other than the Hadoop's core libraries. Had we been using some third-party extra library, we would have to use libjars so that we could include any library and use any function from any third party in our MapReduce. Okay. Now, the next thing which we need to do with any code is creating test cases. The way whenever we are working, we first create the test case and then write the actual code so that we create a way to sanitize our work immediately. Okay, so we work against test case. So we write, first of all we write a test case which will keep on failing because you have not built anything, and then as you keep on building, test cases will become green as you go ahead. Okay, so here I'll show you the test case. The first thing you do is in a test case is setup. While setting up, all right, now again there are two use cases of test case. First, as you just noticed, for every little change, for every minor little change, you have to you have to first compile. First you make the change in Eclipse, then you export the jar, then you upload the jar onto the cluster, and then you run it. And and by, by the time you have gone through these many steps, it'll be too much of hassle, and you won't be able to test all kind of scenarios. So to reduce to reduce time consumed in the cycle of uh, Hadoop MapReduce job, you generally do it offline. The way we tested our MapReduce in streaming by running it on the pipeline, Unix pipeline. Similarly, here also Hadoop MapReduce comes with a Java library called MR unit. It's called MapReduce JUnit library. Okay, what does this library do? This library pretends to be MapReduce, which is running in the local mode. It simulates MapReduce on your local machine. All right, so how does it simulate? Here it provides us this fake driver, fake MapReduce driver. Okay, so you can see there is a fake MapReduce driver. You set the mapper and reducer, and then you can run it. Okay, that's it. We cannot test the driver because we wrote three pieces of codes, right? Driver, mapper, and reducer. We can test the mapper, we can test the reducer, but we can't test the stub driver using MR unit. Why? Because it is the fake driver. Okay, it's a substitute to the driver. Okay, I'll show you some more things. Let me delete these unnecessary files. Okay, now here you can see. Okay, there is a class called stub test. This piece of code is what declares map driver, one map driver, reduce driver, and so on. Then setup code creates these drivers, these objects. You can see that map driver equals to new map driver, and so on. Okay, so we are basically creating these fake mapper and reducers wrapped around our actual logic. So whenever we call mapper.run, they will run instead of Hadoop running it. Okay, now you can see here we are testing the mapper. We are saying map driver dot set input key. So here we are providing input ourselves rather than reading from HDFS, and then we are running the mapper code. Okay, you can see that. Um, we are saying map driver dot run. Similarly, we can test reducer separately. Right now I have set it to fail. Similarly, we have set test MapReduce. Okay, both of the part. So as we have already discussed that whenever you are testing the MapReduce job, first test map and reduce separately and then together. Okay, so you always, while creating your code, you should always make sure that the mapper and reducer are tested separately, and then you test it together. Right now you can see that Mapreduce, we have given the input, we have specified out, we have run it, right? We are running it, this Mapreduce driver, and then whatever is the output, we are going to iterate over it. Now let's try to run it. We say here, run as JUnit test case. What does it say? It's trying to run. The mapper is successful. Mapreduce is successful because we are testing, we are basically testing the output number of elements. Okay. And then inside reducer, we have made it fail by putting this statement. Okay. So you can try this, and this is how you generally test Mapreduce. Alright. So one more part, in case you want your own input format. Although we discussed all kinds of input formats, we discussed fixed file format, key value format, sequence file format, and so on. But sometimes you may want a custom input format. Ideally, you should not be creating a new input format, because creating an input format is too much of a hassle. It's not that straightforward. There's a lot of engineering, and you have to do a think through multiple times in order to write a good input format. Okay, but still that does not mean that you do not know how to do it. Okay, so I'll just take you through it. So first of all, how do you change the input format? First, let's understand it. So the way you change the input format is by going to job and saying set input format. You can see that. You can say set input format class. Right now we have said fixed length input format. Okay. And in case our record length is 15 characters, so we could set that config using the conf object. Okay. And in case you want to create your own input format class, then you will write your class name here. Okay. So and how do you create an input format class? You first extend this input format, okay, and implement get splits and create record reader. Input format's duty is to provide the list of splits, and for each split it creates the record reader, meaning from splits it provides the records. So the main work is done by input format, and sometimes you may want to extend even the input split. By default, input split has only two properties. One, the length of input split, meaning how many records does an input split has. Second, what are their locations with respect to the HDFS blocks. Okay, so these are basically, you define all of these in detail. Okay, and so this input formats, you can see that input formats duty is, given a job context, it should return the input splits. Given an input split, it should provide a record reader. Record reader could be any standard class, or it could be your own class. So you can actually extend pretty much everything and modify pretty much the whole behavior of Mapreduce. Okay, I'll show you an example here. All right, so there is one more project which is there in my home directory. You can see that there is an example of combiner, partition, and custom input. You can download this one. Okay, you can download this one in the same way, the way we did earlier. You can simply download it. Okay, so you can see here it contains almost everything. All right, so you can go here, file, new, project, general, sorry, file, import, and existing project into library. Okay, let's just check what happened. Its name is SG-test. Alright. Okay, so here we go. So here in SG-test, it says the libraries, probably libraries are missing. Okay. The Java JRE not found. Let me remove it and add library and JRE system library. Good. This is fixed. And then check if it is working or not. Good. Looks like things are okay. So here there are a few more examples. One is combiner and reducer and partitioner. Combiner and partitioner. Other is the char count example. And there you will find the custom reader also. You can see that we have created our own input format called nlines input format, which is extending text input format and providing its own record reader. Alright, so we have defined our own record reader. Now record reader's design is a little bit tricky. You should go through this code and yep. So basically the overall idea behind the record reader is pretty much what we had discussed earlier. That record reader gets executed on all the nodes parallelly and it keeps on seeking the record boundaries. As soon as it hits the record boundaries, unless it hits the record boundary, it'll keep skipping the data. And as soon as record reader hits the boundary, it will start parsing and processing the data. Okay, and whatever is before the record boundary gets shifted to the previous task tracker. All right, so this is, you can go through this. It's little you must go through this, okay, and try to understand how does record reader works. Okay, now coming back to it. Okay, so you could go through this. Next we want to talk about partitioner. Alright, I hope everybody's questions are answered. Alright, so a little recap. Yes, Suraj, you are not able to hear me? Think for others it's fine. Yeah? Alright, is everybody able to hear me? Great. Alright, so a bit of recap. So this same diagram which we talked earlier, here it shows that this is the local transfer. You can see this is a minor data transfer that happens while preparing the input split. So input split gets prepared. Input split gets prepared out of the blocks, okay, by using the input format. Input format translates the HDFS blocks into the records, okay, into the input splits, and that input split is fed to your mapper code, and whatever is the result of the mapper code after getting sorted gets transferred to the reducer node. There all these output key values from the mappers gets merged together, and then the reduce function is called on every key and all of its values. Now, what happens when you have multiple reducers? When you have multiple reducers, the map, every key every key value given out by the map function is put into multiple buckets, right? So some keys are put into one bucket, some keys go into another bucket. As you can see here, some keys are going into one bucket, some keys are going into another bucket. If you have 3 reducers, there will be 3 buckets. If you have 20 reducers, there will be 20 buckets here. Now your question would be, who decides which key to be put in the first bucket and which key to be put in the second bucket, right? Who decides this? This is decided by something called partitioner. Partitioner makes sure that partitioner tells Hadoop that, hey, this key should go to the first bucket, that key should go to the second bucket. All right, so this is how a partitioner looks like. Here you have to implement a get partition method, okay, and this get partition method returns a number, and that number represents which bucket should it go to. 0 means first bucket, okay, it starts from 0. Make sense to you? The default partitioner we have is hash code based. What it does is it computes a hash code of the key and then divide that hash code by number of reducers, and whatever is the remainder that defines where should the output go. For example, if some strings hash code is say 10,000 and there are only 2 nodes, so 10,000 divided by 2 is 0, which means the data whose hash code is 10,000 goes to the first reducer. Had it been say 10,001, the hash code is a technique of converting a string into number, right? Again, divide by 2, whosoever is like doing a any miny mo over the reducers, okay? It's like doing the any miny mo over number of reducers. So you can see the 1 2 1 2 1 2, and then wherever it ends, that's where it puts, okay? So it's a standard way of making a decision of who gets the key. All right, so since it's a big number, so it keeps on doing a round robin till the point. I mean, that's what is remainder about. Okay, there's a definition of remainder. Now, if you want to control which key should go in which bucket, you can write your own custom partitioner. For example, here we are saying that all the keys, all the data which belongs to mail should go into the first bucket, which otherwise put it into the second bucket. Here we are saying in case gender is M, return 0. In case gender is 1, return gender otherwise return 1. All right, now let's see, can we put it to use? Let's see if we can put it to use. Okay, now if you remember our code here, let's take a look at a simple driver here. You can see that there is a step mapper, step partitioner, number of tasks is this. Okay, so I'll show you my partitioner right now. It's a second project right now what we are looking at. Okay, let me close the older project. Okay, now you can see that here also we have a simple word count example, just that we are removing non-alphanumeric in by from the word, as well as we are converting the word into lowercase and then giving out. So it's a clean word count. You can see that it's a clean word count. All right. There are a few more things we are doing here. Here we are saying number of reduced tasks is 2. So we can define that parameter in the job. Okay. Now, if you define number of reduced tasks as 2, what happens is, okay, let's say our input words were apple, apricot, bat, and banana. Okay. Now, uh, so what is the output if we have defined number of reduced tasks as 2? How many files will be are there output files? In case number of reduced task is 2. So the number of output files will be 2. Now, which out of these two outputs, let's say first option, I'm giving you two options, first and second, which answer is right? Okay. First option contains two files, let's say part 0 and part 1. Similarly, the second answer contains part 0, part 1. Okay, so part 0 would contain apple, apricot, and part 1 contains bat and banana. And second part contains apple, bat, and apricot and banana. Alright, so my question here is, which one is more probable to you? Second option. That's correct. If you do not believe me, I can show you by running this particular example. Okay? Or you could simply put this in the first example and test it again. I'll show you quickly. Okay? Because that one is running already. So here you can see where is that driver? We have to set this in the driver. Okay, so I'm saying job.number of reduced task equals to 2. Okay, let's take a look what happens when we do. All right, I'm uploading that jar file again. Okay, so I will have to delete this. And then run the okay, so it has started the process. Okay, so let's see if it has created the output folder. Hadoop fs-ls. Okay, similarly you can go to Hue and check if it's created or not. Okay, you can see that the two files have been created. Okay, now what I want to show you is that what is it that is there inside each one. Okay, take a look at it closely. Okay, one of the files first few characters are these, first few lines are these, and second one first few lines are these. Now individually these two set of records are sorted, but if you concatenate these two, they are not sorted at all, because if you see double quote, hash, and here is another double quote and something. Because if you do a sort now, you can see that the records are being merged. Okay, so effectively it's like first record went to first bucket, second went to second, third went to first, fourth went to second, fifth went to first, and sixth went to second, and so on, and again and again. This is what has happened. Okay, so the individually the records are sorted, the output is sorted, but you can't directly merge it. Now that's the problem, right? Sometimes you want to just concatenate the two files so that you get the results. And how would you make that happen? How would you enforce that the data starting from A to K goes to the first reducer, and the data after K till Z goes to the second reducer? How would you make it happen? And that can happen easily if you do this. I will show you. We have done a partitioner which says this. It says that in the get partition, if the key's length is greater than 0, okay, and key is starting, the starting character is less than k, then return 0. Otherwise, return 1. Okay, and based on this, it will start partitioning. And how do you inform the driver which partitioner to use? By using job.setPartitioner class. Okay, if you do this, then it'll be able to use this particular partition class. All right, let's take a look what happens when we use this kind of a strategy. Okay, so we're going to say trg2.jar. Trg, let's call it something more useful. We call it wc clean. Okay, word count clean, and that's it. It says that exported with compiler warnings, resource out of sync, which is okay. We do not want to worry about it. All right. Now let's upload it again the way we were doing for the other one. Okay, let's go to the file browser again and click on upload. Select the files, wc clean, done. Copy it to the local. Okay, I will say minus copy to local and wc clean.jar. Okay, yes. Now let's see if it is running or not. Okay, then we will think about anything else. Okay, what's the name of our driver? It says stub driver and the package name is sg. Stub driver, you can see sg is the package name and stub driver is the name of the driver. Now it's doing the right thing. All right, from here till the end we can copy the same way. Okay. It says that there is no input directory, output directory. Oh, I don't want to do that. What I want to do is okay, I want to say Hadoop jar wc clean this and then let it run and see what happens. Okay. Okay. Now we go into the file browser and see this folder. Okay. Now look at it carefully this time. You can see that all the things up to K. Okay, let's go to the 55th page. Okay, let's go to the page number 55 and then see. Up to J, everything is in a part 0. Okay, you can see that N was coming from the previous line. Okay, so yes, everything is up to J, everything is in a part 0. And after J, starting with K, is in part 1. You can see that? So effectively our partitioner divided the data by our choice. So we use partitioner so that all the words which are starting after K go to the second partitioner and rest go to the go to the second file. All the words that are starting up to K go into first file, and rest go into the second file. Good. This was partitioner. All right. Moving on. We have talked about this. Now, this is something very, very interesting. All right. But before that, I would like to show you my character count example. Okay. All right. So all of you, please recollect our first question in in the subjective exercise, where the job was to find the number of the frequency of characters. Okay, there every node is transmitting a lot of data. Every node, every map task would generate many more keys, as in all total number of keys generated by mapper would be equal to the total number of characters in that particular input split. And all of these characters would have to be taken to the reducer node. Now, don't you think that this is too much of an overhead? What if we could do some kind of processing on the same node before the data get transmitted to the reducer? If we could do some kind of processing on the same node, we would reduce a lot of network traffic, and that's where the combiner comes into play. That's where the combiner comes into play. Look at this diagram closely. Here you can see that after the map, the data is getting combined and then it's passing through the partitioner. So if we could combine the data on every node before it gets transmitted, we would save a lot of bandwidth, as well as it will be drastically faster. Okay, that's where the combiner comes into play. So what is combiner? Combiner does the job of a reducer on individual node, but it does not remove the role of the reducer. Why? Because same key might exist on another node. Therefore, combining keys from multiple mapper nodes needs to be done by the reducer. Okay, so it runs on the same node after map has finished, processes the output of map, and helps in minimizing the number of the minimizing the number of keys being sent to the reducer. But it does not replace the reducer. Why? Because reducer does the merging of data from multiple nodes. Okay, while here the combiner combines all the values for each key on a single node. Okay, so combiner is exactly the reducer. Okay, combiner, you always write a function just like the way you have written a reducer. Similarly, you can define your own combiner which will combine multiple values into a single one on the same node. Okay, but there is a catch. There is a catch that not every function is a valid combiner. Not every function is a valid combiner. Only those are valid combiner which no matter in what way they are applied, the output should be same. For example, sum, minimum, max. For example, so what does a reducer do? Reducer reduces multiple values into one, right? Similarly, combiner combines multiple values into one. Okay, just that there is no guarantee that all the values will be passed to a combiner at the same time. It will be applied again and again and again and again on the output of the mapper. Look at this one. For example, if let's say your combiner function is max, okay, your combiner function, you are looking for maximum of the values for a key. So if your combiner function is max, it might be called first on 0 and 20, and after some time 10 and 25, and then the output of both of that again will be passed on max. So this combiner gets called many more times. This combiner gets called every time there is a sorting effort. Okay, every time the data is getting sorted, the combiner is getting called on every node. Okay, because you don't have luxury of calling the combiner for all the values. Okay, so Hadoop calls combiner as and when the values are available. Therefore, combiner has to have this property that no matter in what way combiner is applied, no matter how many times, the answer is always same. For example, whether you apply max on all values, then also the answer will be 25 in this case. In case you apply max on 0 and 20, and then you apply max on 10 and 25, and then max of 20 and 25, answer will always be same. Okay, no matter in what order, no matter in what way you apply max function on these records, the answer will be same. Similar is the case with sum, min, and there are few more functions. But average or mean does not follow the same behavior. Okay, does not follow the same behavior. Okay, let's take a look. The average of 0, 20, 10 and 25 is 11.25. The average of 20 and 0 is 10, and average of 10 and 25 is 17.5, and the average of these two is this. Okay, so the thing you have to understand is that the combiner, although it combines multiple values, it would be called on partial values and will be called again and again. So you can only have few functions as combiner. Not everything can be a valid combiner, unlike a reducer. Okay, so you have to pay a close attention to what kind of functions be the valid combiner. You will encounter this kind of function again when we discuss the Spark. Okay, all right, so this is a combiner, and basically you can apply a combiner. You can see that in case of character count, we have created our combiner. Okay, you can see that here we would be applying, you can see, set combiner class step combiner. Okay, and it does nothing but same work as what reducer is doing. That's all right, so that is a combiner. So you can try a combiner. All right, tomorrow we will continue with job chaining. Please try to run these projects by yourself as much as you can. All right, have a good day. We'll see you tomorrow. Bye bye.